Welcome you all in my video lecture series on the topic solution of partial differential equation. These days we are talking about the Lagrange's method. So earlier we have already discussed type 1, 2 and 3. Today we are going to discuss type 4. So you can see my previous video for type 1, 2 and 3. This is Brijesh Kumar Jha, Faculty of Mathematics. So let's start the topic. So in this type 4 directly we will go to the question first on and we will see what happens in type 4. But it doesn't matter, you can solve by type 1, 2, 3 also for some questions. Here we have selected example for type 4 only. The first question that is given here, it is y plus z p plus z plus x q is equals to x plus y. So as discussed earlier, we go for the auxiliary equations. So its auxiliary equation can be defined in the form of dx upon y plus z, dy upon x plus z, and dz upon x plus y. Here, this section is what? This is P, this is Q, this is R. So auxiliary equation, that is what defined as dx upon capital P is equals to dy upon capital Q is equals to dz upon R. So by putting the values of P, Q, R, we get this auxiliary equation. You can use any method, but here we are discussing type 4. So what we do in this type 4, we select in this way also. You can see by taking L is equals to 1, M is equals to -1 and 0 for Z and multiply the fraction. Otherwise directly dx minus dy or dy minus dz that we can write here. So what we get, dx minus dy, and denominator will be y plus z minus x plus z. So this z will be cancelled, and what we have, it will be d of x minus y and minus of x minus y that we can get. So in such a way we can frame the fractions. So the number of fractions that can be framed. Same way, other way here you can take dy minus dz, dz minus dx, or dx minus dz, whatever. You can take number of fractions. It means in type 4 we make again number of fractions in the auxiliary equation apart from these three standard equations. So first that we have defined, again what we can do here, dy minus dz that we can take. So it is in the language form that we can say by taking L is equals to 0, this is L, this is M, this is N, but directly you understand dy minus dz. So here the x will be cancelled and the final form will be dy minus z upon minus of y minus z. Same way we can follow again the pattern, the Lagrange multiplier that we can write by adding all the terms that we can say dx plus dy plus dz. So by adding all the terms, what we get, dx plus dy plus dz, and in the denominator every variable will be comes in the 2 times. So it will be 2 times of x plus y plus z, and numerator d of x plus y plus z can be written. In this way we have framed number of fractions, right? You can write dx minus dz also, that can be also possible. So in such a way we can put number of pattern here. Now from these three fractions we will choose two fractions to get the first solution, and again another two fractions to get the another type solution. So it will be easy to get it now. So what we can see, this can be d of x minus y upon minus of y minus x, minus of x minus y can be written here. So this term will be what, d of x minus y upon minus of x minus y. This can be written as d of y minus z upon minus of y minus z can be written. So by taking any two fraction we can have the solution u and v. Suppose we take first two fraction, what we get it here, d of x minus y upon minus of y minus x, d of y minus z. So it is d of x minus y is equals to minus of y minus x, and this is d of y minus z upon minus of y minus z can be written here. So you can integrate it. For the beginners, what we can do, you can put x minus y is equals to t, and this is y minus z is equals to s. So what we can get, dt upon t is equals to ds upon s. So it can be integrable. So what we get, log of t is equals to log of s plus log of some constant c1, suppose we write. The same way, by revert, t is equals to x minus y we have kept here, and s that we have kept here, y minus z. Now you can simplify this. So it is what, x minus y upon y minus z is equals to c1, not log c1. So here we have used the property log of m minus log of n is equals to log of m by n. So for the beginners, you can understand. So log of x minus y here, and this log of y minus z can be kept in the left hand side. So it will be log of x minus y minus of log y minus z. So this formula we have used. So x minus y upon y minus z is equals to c1 is your first solution. Again, another two fraction that you can select. So by taking the second factor, it is d of x minus y upon minus of x minus y, and 2 that we have taken this side. By integrating, what we get, 2 times of log of x minus y, and okay, minus was there, so it will be 2 times log of x minus y plus log of x plus y plus z is equals to log c2, that can be taken here. So by simplifying, what we get, x minus y square into x plus y plus z is equals to c2. So this is our second solution. So by having the second solution, we can say that phi of x minus y square x plus y plus z, x minus y upon y minus z is equals to 0, which is the required general solution of the given question. So I hope so you understand how to use type 4 Lagrange's method. Now we come to the next question. Now let's talk about the second question. Here we have given here that y squared x minus y that you can consider as a capital P, and minus of x square y minus x that you can consider as a Q, and this is R. So Lagrange's auxiliary equation, you know, dx upon capital P is equals to dy upon capital Q is equals to dz upon R. So minus sign should be here, it should be minus of x square. Okay, so by taking first two fraction, what we get here, you can see, okay, so x minus y will be cancelled here, and it will be dx x square dx is equals to minus of y square.